Assalamualaikum warahmatullahi wabarakatuh. My name is Nartika Anwar. We are from Group F. Today I want to explain about abstract and introduction about this project, which is Unipolar PWM. We are first with modulation. Okay, firstly, we know that among many kind of power converter, unipolar PWM inverter have been widely used in reactive power compensator, static frequency change, and adjustable speed AC. The output voltage of unipolar PWM inverter is required to coincide with a sinusoidal command, which can be regarded as a representative control problem. We know that an inverter is a device that connects a DC source such as a photovoltaic cell to an AC network. Unipolar PWM has an efficiency advantage since it has fewer switching losses and produces less EMI. As a result, the content of the total harmonic distortion (THD) in output current and output voltage is reduced. PWM technique with sinusoidal sampling are necessary for single and three-phase inverter. The results are far from the one produced by the optimized PWM. For single-phase application, the unipolar modulation ensures excellent close to optimized pulse duration. Next, inverter are devices that convert electricity from a DC source to an AC load. The control mechanism employed in inverter are similar to the tools employed in a DC-DC converter. This is our poster for the project. In comparison to our bipolar PWM, we know that the current control technology based on unipolar PWM provide higher stability and compensation with loss reduction, efficiency augmentation, and DC offset limitation. The pulse width modulation, which is a PWM, is a technique which is characterized by the generation of constant amplitude pulse by the modulation the pulse duration by modulating pulse modulation. That's for abstract introduction of project. The objectives are the design, implement to use the power simulation software, PaySim to simulate the design circuit, and to prove fundamental risk calculation. That's all for me. Thank you.
In this project. Okay, so this is our calculation. So this value is we set in our circuit simulation. So first we need to find the value of MA and MF. MA is amplitude modulation ratio and MF is the frequency modulation ratio. So V triangle and F triangle must greater than the value V sine and F sine. Okay, V sine we call the reference and V triangle we call the carrier signal. So we put this value inside the formula and we get MA equal to 0.9 and MF equal to 50. So next step we need to find the value of N for this sekat halang for this fast Fourier response signal. So this value we get from the table in our textbook. So next step we simply insert this formula, this value inside this table. So for formula Vn equal to MA times VDC. So we get this value. So this value we get, we put this in this graph. Frequency spectrum for unipolar PWM, ME equal to 0.9. So this calculation part are same with the simulation part. So the value harmonic is started from the MF until 2 MF only. So that's all for me. Thank you.
Assalamualaikum and hi, I am Amira. This is simulation circuit for unipolar switching scheme for PWM. As we can see, they have two types of circuit, which is full bridge inverter, and control circuit. For full bridge, we use MOSFET as switching point. To get pulse, we use control circuit. In control circuit, we use two types of input, which is sine and triangle voltage. This circuit used as comparing the sine and voltage triangle. So, for full bridge inverter, we use 100 volt for VDC, and for control circuit at voltage triangle, we use 750 Hz for frequency. For V sine, we use 50 Hz frequency. And now let's see what happens when we run the simulation. So first we show voltage triangle and voltage sine signal. Then off for S1, off for S3, and then VAB is V out. Now we can adjust the signal, the waveform, to easy for us to see. Okay, so I use 0 to 0.02 range for easy to me to read the waveform. Okay, so when we give pulse at S1 and S3, means if we turn on S1 and turn on S3, we will get the result is 0. But when one of these switch is turned off, the result will get plus VDC. That's why at this point, here we can see positive half cycle, and then we see here negative half cycle. And now let me show you the FFT for the VAB. Okay, so this is VAB output. So I would like to show you how FFT works. I adjust the range to 4500 and the grade I put here 6. Okay, now we can see this is 2 MF spectrum frequency, and this is MF. From here we can compare with calculation, and then we can get same as like this. This is result for calculation that we already made in the report. That's all from me. Thank you.
Okay, for the conclusion, the PWM Unipolar has an efficiency advantage since it has fewer switching losses and produce less EMI. All these advantages has proven when we do a simulation, and the project has achieved the objective, which is we able to design complete switching strategy for inverter application. The PWM Unipolar inverter has many circuits, but in this project we use control circuit and an inverter circuit. So all the circuit have been designed successfully. So the calculation part and the simulation part we got are almost same, and we able to produce the waveform for the control circuit output, inverter circuit output, and the fast Fourier transform signal that has been created using the inverter that have been developed. So this is the example reference that we refer. So mostly we refer to our textbook. So commonly used power and converter